Alright guys, welcome to 7.3 Rational Exponents. So up until this point you guys have been dealing with some division properties of exponents, some multiplication properties of exponents. So now we're going to deal with fractional exponents and get into some radicals as well. So to start us off, I want to just take a second to talk about what b to the 1/2 is. And I'm going to use something that hopefully we already all know. What I'm going to do to demonstrate what this means is I'm going to take this and I'm going to square it. Okay. Now, hopefully you remember that if you have a power, such as a half, so this is like b to the 1/2 power squared, when I do a power to a power, when I take a power to a power, I multiply these two things out, right? So if I have b to the half squared, 1/2 times 2 over 1 equals 1. So this is the same thing as b to the first power. Okay, I demonstrate that because that's basically essentially it just undoes the exponential and I'm left with my base b. So squaring undoes half roots. Okay. So what is the opposite of squaring something? Well, the opposite of squaring something is taking its square root. So b to the 1/2 simply means the square root of b. In fact, if you want to be very specific about it, since there's 1/2 there, this is like taking b to the first power, that's where the 1 is, and this is taking the second root of that thing. Okay, so you'll see how that ties into this lesson shortly. Oh, I didn't even give you guys the examples. Hopefully these are in your notes, but luckily I have a textbook here. Example 1a says let's take a to the 1/2. Okay, so if I do that, that's the same thing as taking the square root of a. So the directions for example 1 is to write the expression in either radical form, or if it's in an exponential form like this, so if it's in an exponential form, write it in radical form, and if it's in radical form, write it in exponential form. So like for instance 1b, we have the square root of 22. They want you to write this in exponential form and get rid of this radical. Okay, so what's another way I could write that? Well, hopefully now what you're seeing is that's the same thing as 22 to the 1/2. Okay, so I can rewrite that 1/2 power means square root. Okay, so let's look at a couple more here. 1c is taking 7w in parentheses to the half. Okay, that's the same thing as writing this as the square root of 7w. And then 1d, we have 2 times the square root of x, which is the same thing as 2 times this x to the 1/2 power, or we can just write that as 2x to the half. Okay, so example 1 is just helping you to see that half power really just means square root. All right, let's keep going here to the nth root. So for any real numbers a and b and any positive integer n, if a to the n is equal to b, then a is an nth root of b. Okay, so that's an official definition. Let's see what that actually means here with a couple of examples. So we have example 2a, which is the third root of 64. Okay, so for this thing, is there any way that we can, so for this, what I would prefer that we do is think about this as, is there anything that I can multiply by itself 3 times to give me 64? Okay, that's like taking a third root. So what I like to do is go back to like some principal roots. So some principal roots are things like, okay, what happens if I take 2 times 2 times 2? If it's a third power, multiplying that base, the same base by itself 3 times, right? So if I did 2's, it would be 8. If I did 3's, 3 times 3 is 9 times 3 is 27. If I did 4's, 4 times 4 is 16 times 4 is 64. Okay, so there it is. The third root of 64 is equal to 4. This is because 4 to the third power is equal to 64. Okay, so basically taking the third root undoes the third power. So for instance, if I took the third root of both sides here, okay, take the third root of 4 to the third, I get 4. If I take the third root of 64, I get 4. Okay, so basically taking any kind of root is undoing a power or an exponential. All right, so that's how we do 2a. 2b, they want the fourth root of 10,000. So they're asking what number multiplied by itself 4 times gives me 10,000. So, you know, the most straightforward thing that I could try there would be 10, since we're dealing with a bunch of zeros and a 1. So if I do that, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, and sure enough, that is it. So the fourth root of 10,000 is just 10. Your calculators can do these as well, so you have to look up how your individual calculator does these types of things. But for now, if you don't have one, you're just kind of thinking, what thing can I multiply by 4 times to give me what's in here? Okay, so now we have b to the 1 over n. So for any positive real number b and any integer n that's greater than 1, b to the 1 over n is equal to simply this, the nth root of b to the first power. Okay, so if I have b to the 1/5, that's the same thing as the fifth root of b. Okay, so let's play with that for a few. The example that they give us here is we have 8 to the 1/3, which is equal to the third root of 8, which is equal to, so this is just saying like what thing multiplied by itself 3 times gives you 8. Excuse me. And the answer to that is, well, let's start with the first one. 2 times 2 times 2 gives me 8, right? So this would be 2. So the third root of 8 is 2. Okay, example 3a, we have 27 to the 1/3. So one way to think about this is just saying, okay, we have the third root of 27. Okay, what number multiplied by itself 3 times gives me 27? And the answer to that would be 3, right? 3 times 3 times 3 gives me 27. So 3 to the third must equal 27. So the third root of 27 must be 3. Okay, so that's example 3a. For 3b here, we have 256 to the 4th power. Again, we can write that as the fourth root of 256. Okay, and if your calculator is struggling with this one might be a little difficult, but we can start with 2, right? Because we're doing fourth powers now, essentially, right? We're undoing fourth power. So 2 times 2 times 2 times 2 gives me, what is this, 4, and this is 4, so that would give me 16. Okay, so that's nowhere near what I need. If I did 3 times 3 times 3 times 3, this is 9. 9 times 9, that's 81. So that's not there. If I did 4s, that grew pretty quick. You know, that grew pretty fast, pretty quick. So I'm going to try 4s. 4 times 4 is 16. 4 times 4 is 16. So I multiplied these by these. And then I got to multiply the 16 times 16. And sure enough, that gives me 256. So 4 to the 4th equals 256. Therefore, 4 is the fourth root of 256. All right, so that's example 3b.